This is R.d.sharma solution class 12th. We are taking exercise 19.25 of chapter 19, indefinite integrals. Now we have x to the power n log x dx. So the first thing is what or which one to be taken as the first one and the second one. Normally we take the algebraic expression as the first equation, but there are certain things, so there are certain places where the case may not be. If you take x raised n as the first function, integration of log x will come, and that will create a trouble for us. That means we will get stuck. We have to assume this log x as 1 into log x, then again have to apply the same formula. So rather than doing this, we'll take log x as the first function and x to the power n as the second function. That is, log x first function, integration of x to the power n is simpler, minus integration of d by dx, that is differentiation of the first function, which is log x, then the integration of x to the power n, and these two, differentiation and integration, when multiplied, it has to be integrated. This is log x, x to the power n will be x to the power n plus 1 by n plus 1. It is actually the standard formula of x to the power n. Now what is log x differentiation? It's 1 by x. X to the power n will be what? It will be x to the power n plus 1 by n plus 1. So x to power n plus 1 into x to the power minus 1, because x goes up. N plus 1 is a constant, remains in downstairs. 1 gets cancelled because it will be, the power will be added, n plus 1 minus 1, that will be x to the power n by n plus 1. So this now has to be integrated. So this 1 by n plus 1 can be taken outside, it is just a constant. And integration of x to the power n has already been done, which is x to the power n plus 1 divided by n plus 1 plus a constant of integration. Now this denominator will become n plus 1 whole square. So we have n plus 1 whole square, you can take common because this is the denominator. I'm just making it simpler. Answer we have already got. I'm just taking denominator n plus 1 square common, x to the power n plus 1 from the numerator common. Whatever is left can be kept inside. So the second term we have already taken outside everything, so only 1 will remain. The first term x raised n plus 1 by n plus 1 whole square has been taken common. So n plus 1 will already be there, and then with the log x. So there are different ways to represent the answer. So the approach remains the same. Maybe the answer is different because just how the simplification has been carried out at the end. So kindly write the English sentences also wherever it is required. Now log x divided by x to the power n dx. Now log x integration will be again a different task. So rather than doing this, we will take log x as the first function, x to the power n as the second function. So integration of x to the power n, x minus 1 will be going upstairs. So this x to the power n can be considered as x raised minus n. We will take u as log x and v as x raised minus 1. So log x as the first function, then the integration of the second function, which is x raised negative n, then d by dx of the first function, which is your log x, and then we have x to the power minus n, that has to be integrated. Then we will close everything, and this comes with the dx. Now x raised minus minus n has a direct relationship or direct solution, x raised negative n plus 1 by negative n plus 1. You can write it in a better way, like x raised to the power 1 minus n in the numerator, and denominator of n minus n plus 1 can be written as 1 minus n. How about the second part? Log x differentiation is 1 by x, and x raised minus n has already been integrated. So let's like the actual result here. Now x goes up, x raised minus 1. Now the power gets added, so 1 minus n minus 1. So 1 gets cancelled, it will be x raised minus n divided by 1 minus n. Now this has to be integrated, alright. So 1 by 1 minus n, you can take it outside because it's just a constant. But the integration of x raised minus n has to be done. So x raised minus n plus 1 divided by negative n plus 1, that will come. So this will be x raised 1 minus n plus 1 can be written as 1 minus n, and 1 minus n in the denominator. Now you can just simplify it or write in a way so that it seems to be simplified. 1 minus n square I am taking from the denominator. Since 1 minus n has been taken, 1 minus n will come in the numerator. And here everything has to be taken because we are going to take x raised 1 minus n also from the numerator. So take this x raised 1 minus n. This 2 has been taken. So 1 minus n will remain and log x will of course remain. So let me just write this log x also. And in the second part we have, or the second term, we have taken everything. So only 1 will remain. and plus the constant of integration, of course. So this is how this question will be approached. This is the reference for your if you are actually doing it by yourself or you want some kind of say reference. Now x square sine square x dx. This sine square x has to be converted into some formula, because even if you take it as the first function or second function, we will get stuck somewhere. We know that this sine square x is 1 minus cos 2x by 2. Same way cos square x equals to 1 plus cos 2x by 2. So x square has to be taken as the first function. The second function will be 1 minus cos 2x divided by 2 minus integration of what is d by dx of x square. So d by dx of x square, integration of 1 minus cos 2x divided by 2, and this whole has to be kept inside a dx. So this will be x square. Now 1 minus cos 2x by 2 has to be integrated twice. That means it is seen twice. So let's do it separately and then we'll put the result. The half or the 2 in the denominator can be taken outside. So we just have to deal with integration of 1 minus cos 2x. This is simply integration of 1 dx minus integration of cos 2x dx. Integration of 1 dx is simply x, and integration of cos 2x will be sin 2x divided by 2. So x minus sin 2x by 2 here, and same thing has to be written in this place also. But the differentiation of x square has to be done, so it is 2x. And integration of 1 minus cos 2x, you can just directly write x minus sin 2x by 2. Now this 2 gets cancelled because 2 can be taken out and it will get cancelled. Now let us multiply the first two terms. It will give x cube by 2 minus x square sin 2x by 4. So first and second term we have got. How about the third term? So we will multiply and then we will integrate again. So this is going to be x square. Integration of x square has to be done. And the second part is sin 2x, x sin 2x divided by 2. So this you can directly write, you know the result of this integration. It will be x cube divided by 3. And this x sin 2x by 2 has to be done again. This 2 will just keep it temporary and we will just employ it in a short while. But before that, we'll do this x sin 2x. Please remember, a negative sign is in front of it. So x as the first function, sin 2x as the second function, minus d by dx of the first function, which is d by dx of x, and the integration of the second function, that is integration of sin 2x, and this whole with a dx. So x sin 2x is what? Sin 2x is negative cos 2x, and differentiation of 2x is 2, so we divide it. D by dx of x is 1. Integration of sin 2x, see, it will be cos 2x and negative will come. That is why negative we have written. And integration of again cos 2x has to be done. Cos is sin only, so the sign remains the same, minus half sin 2x. Again a 2 will come because 2 has come from sin 2x to cos 2x. Now cos 2x to sin 2x, again a 2 will come. So half was already there outside. So let's multiply it inside and just write it in the final result. So this will be minus x cos 2x, and this will be 4 minus, this will be 8 in the denominator, 4 to 8, sin 2x will be in the numerator. And this will become plus because negative is positive. And a constant of integration, of course. That's your final answer. Now how to do this? This is the way you are going to write it. Now there are certain questions which need certain assumption or replacement. Then they will become very easy for our integration purposes. Because if you see, x cube differentiation will be x square. But with this x square is actually to the power of e. So we cannot utilize this thing. But what we can do is we can write x cube in this form, x square into x. So if you take x square equals to t, you will get what? I'll just show you. First, just reorganize this. X cube can be written as x square into x. This can be written. So x cube is done. This 2 has to be kept along with x. So it will be 2x. E to the power x square is already there. Now how this x square equals to t will help it? See, x square equals to t, e raised t, and this 2x is the differentiation of x square. So dt by dx will be equal to 2x. dt equals to 2x dx. dt by 2 is x dx. So 2x is already there, so we can just write a dt in place of it. Now x e to the power x question we have already done. So wherever this t is there, so t integration of e raised t minus integration of d by dt of t and integration of et again. Please remember, integration of e to the power anything will always be that that thing only. Number of times you integrate doesn't matter. Number of times you differentiate doesn't matter. So integration of et will be e raised t only. D by dt of t is 1. So integration of et will be e raised t only plus a constant of integration. Now you can take e raised t common from this one and only t minus 1 remain inside plus constant of integration. But t was what? T was taken earlier as x square. So this becomes e raised x square and this will be x square minus 1 plus constant of integration. So this is how it is going to be written. You have to just tell the examiner you know all these things. So just write it also. X cube cos x square dx. Now again we have an x square and x square can be gained from x cube. So this needs some replacement. Integration of x cube can be written as x square into x. We have a dx along with this. Cos x square. So x square can be taken as t. Dt by dx will be equal to 2x. So we have dt by 2 that will form x dx. So this x dx is simply dt by 2. Half can be taken outside. X square was taken as t. Cos x square is cos t. Now t cos t is quite easy to integrate because x cos x and x sin x integration already we have done. So x cos x can be integrated easily. X as the first function, cos x as the second function minus d by dx of the first function which is x, integration of cos x and this dx. X, cos x is sin x, d by dx of x is 1, cos x is sin x and integration of sin x is what? Minus cos x. This whole will come as sin x, then this has to be integrated again. So minus minus become plus cos x. But there is a slight mistake I have committed here. I have to write t everywhere. After this assumption t equal to x square, I have written x. Just assume that this all x is t only. So let me rectify my mistake. I am writing t sin t. So wherever it's x, it's t only. So t sin t plus cos t plus constant of integration. So t equals to x square. Let's write this x square here. Sin x square. 1 by 2 was already there. So 1 by 2 you can just multiply. Plus cos x square by 2 plus constant of integration. Even if you have c by 2, it doesn't matter. It will be a constant of integration only. Now how this has to be done? And this is a good question because it needs some assumption also and the final version also. Now this is x sin x cos x. So x sin 2x we have already done. So we know that how to formulate this thing. Because sin x cos x can easily be written as sin 2x. So 1 by 2 it comes out. You get 2x sin x cos x. Now this 2 sin x cos x can be written as sin 2x. So 1 by 2 integration of x sin 2x and dx. So there is no replacement required. We can integrate it directly. X integration of sin 2x minus d by dx of the first function which is x. Then the integration of the second function which is sin 2x. And then we have a dx. So these both have to be multiplied and then result has to be integrated. So x sin 2x is what? It's minus cos 2x divided by 2 because 2x has to be differentiated and 2 will come, that has to be kept in the denominator. Minus this again sin 2x will be minus cos 2x by 2. So the first integration will give you minus cos 2x by 2. So let me make it as plus. Now we have to integrate cos 2x. Half I am taking outside. 1/2 is already there with us. So minus x cos 2x divided by 2 and this is half. Cos 2x will be sin 2x divided by 2 plus constant of integration. But please remember half was already there. This was kept temporary by me. Now this half has to be included. So all the denominator, either they don't have a denominator, they will get a 2 or they will be multiplied by 2. So negative x cos 2x by 4 plus sin 2x divided by 8 plus constant of integration. That's your final result. Okay, this is how this has to be done. Alright. The key idea of this question is to make this sin x cos x as sin 2x. Other things will be quite easier. Now sin into log cos x dx. Now this is a different kind of question. So you need to concentrate it very well. See, cos x can be gained from sin x and vice versa. So if you take t as cos x, dt will be what? dt by dx will be what? It will be, we are differentiating, remember, it will be negative sin x. So minus if you take on the left, it will give you dt, negative dt as sin x dx. So sin x dx is negative dt. So this sin x and this dx will formulate negative dt. So let's write it. Integration of negative dt. So minus I can take outside, dt I can keep it here. And log cos x. Cos x has already been assumed to be t, so it will be log t. Now log t integration directly will be a difficult task. So let's assume that we have a 1 along with this. So assume that we have 1 here, which can be taken as first function of the second function. Of course, we have done a question like this, so you already know which has to be taken as the first function. So log t has to be always taken as the first function, because integration of log t will again stop us from proceeding. So integration of 1 dx and minus integration of d by dx of log t and integration of 1 dx, because 1 is what we have assumed to be the other function. It's all dt, right? Wherever I'm writing dx, it's dt only, because we already assumed t equals to cos t. Now 1 dt will be what? It will be t only. So t log t we can write. Here also d by dt of log t will be 1 by t, and integration of dt will be t. So actually this t by t will get cancelled out, and we have to just integrate 1. So integration of dt has to be done. So what this will give us, integration of this 1 will be t only. Now negative is already there, so negative, if you multiply, this can be swapped, or you can write t minus t log t plus constant of integration. Now t can be taken outside, so 1 minus log t will come inside plus constant of integration. What is t? It's cos t, cos x. So let's write this as cos x, 1 minus log, what is t? It is cos x plus constant of integration. That's your final result. Okay, this is how we have to do it. I've explained it to you entirely, but there are certain things writing actually. The English like these and symbols and the equality, all this has to be written explicitly. Now log x whole square and x. So we don't need any replacement here, just need to concentrate on which one has to be taken as the first function and the other as the second function. So log x whole square, this is the first function, and the second function will be x dx. So integration of d by dx of what? Log x whole square, and then integration of the x dx, and then whole, this has to be combined, and then this has to be integrated. Log x whole square will be x dx will be x square by 2, and this x dx will again give you x square by 2, so let's write x square by 2, but log x whole square will be 2 log x, and log x differentiation will be 1 by x. So 2 log x divided by x dx will be x square by 2, you already know that. Now this 2 gets cancelled, 1x gets cancelled, you are left with x log x. So actually you have to integrate x log x. So we'll just integrate it again, and then we'll put the answer in this second step. And you already have done x log x. So log x has to be taken first function, integration of x minus integration of d by dx of log x, and the integration of x, this both has to be multiplied, and the result has to be integrated. Log x, integration of x will be x square by 2 minus d by dx of log x is 1 by x, integration of x is x square by 2, so this will be x square log x by 2. So this will be x square log x by 2, because it needs no integration now, result has already been achieved. But there is one more thing, which is integration of x square by 2x. So 1x you can cancel, this 2 can be brought before, and x integration is simply x square by 2. 2 was already there, x square by 4 has come. So let me put it here. It was negative, so negative will become positive. So positive x square by 4 plus constant of integration, that's your final result. Okay, this second part we have integrated separately and then fit in the result. You want to make it more simplified, you can just take this x square by 2 common. When you take this x square by 2 common, log x whole square will remain. Here log x will remain, because x squared by 2 we are taking outside the bracket, and x square by 4, so only half will remain here. That's your result, final result. Okay, this is the result which we need to follow. Now e raise under root x. Okay, now there is certain thing which you need to understand. Root x, if you take root x as t, differentiation of root x is 1 by 2 under root x. You know already that. So can we have this root x somewhere in the denominator so that we can take this root x as t? Yes, we can do that. You will just see how we reformulate this question. This integration can be written as e raised root x multiplies by root x by root x. Now why we have done this? Now this root x can be taken as t. When we take t equals to root x, dt by dx will be equal to 1 by twice under root x. So this dx by root x, if you take dx on the right, twice of dt will be dx by root x. So this can be written as 2 dt, 2 you can take outside, this is dt. And this root x is of course taken as t, And this e to the power root x can be taken as e to the power t. So t multiplied by e to the power t has to be integrated. We'll just keep this 2 in temporary memory. We'll use it later. T integration of et dt minus integration of d by dt of t. T we have taken as the first function, e raised t as the second function. The same thing we'll have to write here, integration of et dt. Now this e raised t, either integrated or differentiated, doesn't matter, it will be the same result. D by dt of t will be 1. E raised t, how many times you integrate or differentiate doesn't matter. It will be e raised t only. E raised x, e raised t. So integration of e raised t you have to do. This will be e raised t. Again integration, e raised t. Though we have no change at all here. So e raised t plus constant of integration. Now you can take e raised t common. T minus 1 will become inside the bracket. T was under root x. So e under root x and root x minus 1 plus constant of integration. So 2 was already there. So just multiply it by 2. That will form the final answer. Now this is how it has to be done. This is the reference which you can employ to solve it. Now the whole idea is to assume root x equals to t. If you can assume that after your practice, then it will be easier. Now this next question can be done in the next part. Till then, thank you so much. Take care of yourself.